Hello, everyone. Today we're going to talk about what engineering school does not teach you. I'm Engineer Elaine, and I am here to help you navigate your engineering career journey. So it's important to realize that when transitioning from school to the professional engineering working world, that engineering school will not have taught you everything that you need to know. They can't. They simply don't have the time to go into the level of detail required. So today we're going to talk about what are some of the key things to know and realize as you make this transition from the purely academic school side of the world over to the professional engineering working world. So the first is there is no 100% answer. There is no answer key. There is no answer in the back of the book. So in school, much of the time, there is a correct answer. And oftentimes, working with a professor, maybe your professor will give you partial credit as you work through a detailed solution for maybe for the approach to the solution, but there is very much an answer to the problem or question that's posed on homework and exams. In the working world, there is rarely ever a correct, perfect solution because perfection would cost a lot of money in order to achieve. Oftentimes we hear, what is good enough? Or a common phrase is, what is the 80% solution that we are looking for? Because 80% is often the good enough metric to move forward. And the extra 20% would cost a lot of time, money, resources to get there. So it's all about convincing the decision maker what is good enough. So presenting the analysis, presenting the approach, presenting the results of testing or the analysis that was produced, and convincing that decision maker. And the decision maker, it may be your boss, it might be your team lead, but there is somebody in the decision making chain that has to make a decision and decide, is this good enough to move forward to the next steps? Or is there some additional work that needs to be done? We need to go back and do that additional work. But rarely is there ever, 100%, perfect solution to a lot of the problems that we work on as engineers. The second thing is what I'm going to call integrative operations. So in school, you have very discrete, very siloed, very parsed out way of working, meaning you have your math science classes, you have your engineering classes, you might even have some electives that focus on economics or business or even the creative things like art and music. Or there's also your English classes, right, where you're doing a lot of reading and writing. Those are all very discrete, meaning there's different times of the day and the week that you meet. There's different professors that you have to answer to. And so you can structure your week thinking about, okay, today I have an English exam, or tomorrow that physics assignment is due. And it is all very, very, discrete and compartmentalized. In the working world, it is all mixed together. So you will not have time to focus on just, one thing at a time. You'll be focusing on many things all at once, and you will be mixing all of these skills together in order to do your work. So math and science are usually pretty closely tied together, but I will say math also includes financial analysis and resourcing analysis. A lot of the writing and reading that you'll do, that's where you're going to pull in those analytical skills that you learned in English classes, even down to thinking about how you're going to communicate something to your supervisor or your boss. If it's in an email, if it's even in a text message or a chat, you're going to be thinking very clearly about what are those words that you want to use in order to communicate what it is that you want to say. When you do presentations, that's going to draw heavily on the communication skills that you have, the speaking skills that you have, and also the ability to tell a story clearly. And also, in some ways, creative and artistic skills, meaning the visuals that you use on the screen to enhance your storytelling, that involves a creative artistic component as well. How you present the data, what are the graphics that you're going to use to illustrate your points, what are all of the different, even color choices that are on the slides. All of those can evoke a very different response. So in summary, it's just to know that all of these skills are going to be tied together. You won't have specific times of the day where you're just focusing on one type of skill. All of your skills are going to come into play as a professional working engineer. The third is that engineering is a business function, and it's important to realize this early on. In school, a lot of it is focused on the technology of the engineering. You're creating something, you're designing something, you're presenting something that you and your team did, but it is all very much focused on what it is you're creating, and a lot of that is tied to the technology. In the working world, in the professional engineering world, it's important to know that the end goal of any organization is either to make a profit or fulfill a mission. And all of that requires time, resources, people, and money. So rarely is it ever just a decision is made just on the technology alone. All of these factors play in to an engineering solution. So you may have an elegant technical solution, but the person making the decision may determine that now is not the right time because maybe it's too high of a cost. There's other cost factors that are involved in maintenance of it or production of it. There may be risk involved. And in the professional engineering world, you're going to hear a lot about discussion of risk. There's technical risk, there's schedule risk, there's financial risk, there's even political risk, meaning the politics internal to an organization. All of that comes into play. And in some cases, it may just be timing. It might be timing of the market or timing of where the organization is at that point in time. So knowing that all of these factors play in, and engineering is one piece of how a business functions. Fourth is teams and more teams. So in school, you may have gotten a lot of experience working on teams, and it may have been a team working on a specific project. Many have like a design project that they're working on and present, in like a capstone senior design type review for that project. At work, you're definitely going to have projects teams, but you may be on more than one project team. You may also be on a functional team, meaning the function of how your management chain is structured, reporting to the other teammates that are within the same supervisory chain that you're on. There may be sub teams even formed within teams. So if there's an issue or a problem, or a specific topic that needs to go be worked a little bit more detail, those are what tiger teams go do. And some teams are so large that they get broken into more and more sub teams that all feed up into a greater team effort. So just know that you may have experience working and focusing on one specific team when in school, but just know that you are going to be present and working in many, many different types of teams in the professional working engineering world. And that is where the relationship and people skills are going to definitely come into play. And then finally, there is an area I'm going to call the systems thinking and understanding the other engineering disciplines. So in school, often we get parsed into our major areas. So mechanical engineers study mechanical engineering, electrical engineers focus on electrical, chemical, civil. You have kind of those main areas of engineering, and you focus on your main area of study in those engineering disciplines. But in the working world, it's more the systems thinking. So you're going to be exposed and working with a lot of different areas across engineering, across science, across technology. And knowing and understanding what all those are help you to become a stronger engineer. So, for example, a mechanical system is not just a mechanical system. There's going to be materials involved. There's going to be all of the interfaces of how subsystems interface with each other, all the way up to an integrated system. There's going to be potentially electrical and signal processing that goes on. And then there's going to be hardware that's integrating and interfacing with software, right? There's going to be all of these other areas that feed into the technical discipline and other disciplines that you're going to be working closely with. So I would say that as an engineer, it's good to be observant and to learn as much as possible about all of those other areas of engineering and science and technology that that touch your area that you're working in, because it helps to learn the language of the other disciplines. The more fluent you can become in those other languages, the more you have the chance to move up, in the whole engineering and management chain throughout your career. So overall, school provides a really good foundation of like the basic skills. They provide you within a really short amount of time, within 4 years for an undergraduate degree program. They provide you that really good foundation of what engineering is and how to do research, how to find information, how to answer to project needs, things like that. But know that when you enter the engineering working world, there's a whole lot more that goes on. And so that's why I'm here to kind of help you through what that engineering journey looks like. The main thing is to always be learning, always be observing, and always be open to gaining more skills, because learning doesn't end just because you graduate from school. You're going to be a lifelong learner, as an engineer working in the professional engineering area. So I hope this helps. I want to thank you for taking the time to listen on this, and I hope this information helps you on your engineering journey. I'll see you in the next one.